Well, hello everyone. Today we are going to jump into the next module of Chapter 9, which is Module 27, on human alteration of water availability. And you need to pay close attention to these learning goals at the front here because they are going to be what guides you to complete your end of the week project, if you will. And so these questions are going to be very important for you to be able to answer. So after going through this set of slides, you should be able to compare and contrast what levees and dikes are. What are the benefits and costs of building dams or aqueducts? And then lastly, to be able to describe the processes of two forms of desalination, which are distillation and reverse osmosis. This next slide takes us into levees and dikes, and their purpose is to prevent flooding. They're kind of used interchangeably. It just depends on where you are in the world, but I think for just basic understanding, you need to understand levees as systems that basically keep river water from flooding local areas. And I want you to see here, this is a levee where I'm taking my pointer alongside of the banks of the Sacramento River right here. And notice that the farmland or the agricultural area is below the river level. So if something happens to the levee, which even just natural erosive processes weaken these levees and levee systems, it can cause flooding across a great expansive area and actually do a lot of damage to the surrounding area. So the levees right now in the state of California in the Sacramento River Delta are actually kind of a hot topic. Many people are concerned about the strength of the levee system overall. There are a lot of levees being used to control river water in this area, and so it's of great concern to farmers in the region and landowners, the strength of these levees and what kind of funding is being exercised to protect and maintain those levee systems. Just another hot topic for California to debate over. This other picture over here shows you a picture of a dike, and this is a common Dutch dike. So the Dutch, their country is basically backed up against the North Sea, and so they have a lot of ocean water that they try to control so that they too can have use of the land and use it in an agricultural way to feed themselves. And so you can see here you've got this, enormous length of ocean and seawater that's just basically going up against tidal motion. It's going up against this dike, constantly, 24 hours, 7 days a week. So the maintenance of these dikes in this area of the world is also a very hot topic, one that they're continually facing year after year. Concern over whether or not they're going to be able to keep rising sea levels out of their agriculture and their residential area that they live. So I'd like to come back to the link here on the San Joaquin Delta levees, because I think as a California resident you should be very familiar with that piece and how it impacts us locally. This next slide here is going to show you a couple of pictures of dam versus reservoir, and over here I have a picture of a fish ladder. So I actually showed the class on Thursday the funny little innovation of the salmon cannon, and we had this discussion about how salmon, as a part of their normal life cycle, they actually swim upstream to lay their eggs, and if you have a dam in the way, such as this one here, the salmon can't get upstream and complete their normal life cycle. So what scientists have done is they have created these fish ladders which allow the fish to kind of hop from one area to the next, to the next, to the next, so that they can get up into this backwater area, reservoir area up here, so that they can lay their eggs and complete their life cycle. Over here on the left, we have a picture of the San Pablo Dam Reservoir, which is right in our backyard. It's less than a half an hour away, and maybe someday you'll be able to go there for recreational purposes. You can rent boats there, go fishing. They actually row on this lake. There's rowing teams that use the lake. But it's a huge recreational area, and it's right in our backyard. But what I wanted you to see from this aerial view is that the reservoir, this water lake region back behind, is being held back by this earthen dam. So the San Pablo Dam is an earthen, kind of a combination earthen and man-made dam. But it's kind of, overwhelming when you drive the San Pablo Dam Reservoir Road. You can look back at this area and just to know that there's this expansive lake, deep water reservoir being held back from you by this dam is kind of overwhelming. So if there was ever a breach in this dam, there would be a huge amount, hundreds and thousands of gallons of water that would just go down and basically flood the cities of San Pablo and parts of Richmond until it met the San Francisco Bay. But this one's right in our backyard. It's kind of interesting. This next slide defines what an aqueduct is, and so California has its fair share of aqueduct system as we work to relocate water from one region to another. As you probably know, Northern California sends a lot of water to Southern California. And so we've had lots of contentious debates between the movement of water from Northern California to Southern California. Some people would like to separate into a Northern California and a Southern California as two separate states. These water wars and these water discussions get really, really, hotly debated. So anyways, an aqueduct is basically an invention that was created hundreds and hundreds of years ago. It's basically a canal, a ditch, or a pipe that's used to carry water from one location to another. But this is huge movement of water. It's not like taking a garden hose as a pipe or a small ditch. These are huge, huge structures that are moving water. In the United States, both Los Angeles and the New York City itself depend on aqueducts to meet their daily water needs. And it comes from watershed that could be hundreds of miles away. So again, you can see these are huge, huge infrastructures that move the water. And this last bullet point just kind of raises the point again that there are consequences of moving water from one location to another. It's kind of like robbing Peter to pay Paul. And with that comes a lot of environmental degradation and a lot of environmental concerns as water is being moved from one place to another. This next slide is important for you to see because it shows you California's watershed and major water projects. And so this one's very important for you to understand as a Californian. Basically, this blue area or this blue line is going to be all of the watershed that basically drains through different forms of precipitation. All of this water is going to find its way wherever you are. This is the Sierra Mountains. The water is going to come down out of those mountains and into California's Central Valley. There's two major rivers. The Sacramento River in the north begins up at Lake Shasta, and then we have the San Joaquin River, which actually has its head in the southern Sierra Nevada. So we have these two major rivers, one flowing north, the Sacramento River flowing south. And where do they meet? Well, we're very lucky. They meet in our backyard, which is the Sacramento River Delta region. And so if you've ever had fun jet skiing, boating, swimming in the Sacramento River Delta, it's right over Highway 4 going towards Antioch and Pittsburgh. You're right there along one piece or one area of this very large, expansive delta region. So then this little area right here is where the delta is located, and that's where the Sacramento and the San Joaquin drain into that area, and it keeps flowing until it meets the San Francisco Bay and then makes its way eventually through the San Francisco, through the Golden Gate Bridge and out into the Pacific Ocean. The other feature that I want you to look at on this map is the California Aqueduct that stems right here. It's in brown, and it stems from the Sacramento River Delta region all the way down. If you've ever driven along Highway 5 down to Disneyland, you have crossed over this California Aqueduct on several occasions. It makes its way all the way down, 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 all the way towards Los Angeles and San Diego. The other interesting piece that I want you to see here is the Colorado River Aqueduct. So this is an aqueduct that also helps to provide water to Southern California. And this aqueduct is taking water from the Colorado River, which is also contentious and hotly debated. Sadly, we take so much water from the Colorado River that when it actually meets the Gulf of this area down here, Gulf of, I'm at a loss of words, the river's actually dried up several times during the year because we take so much water from the Colorado River. So sort of sad, and it can be devastating. This next slide discusses the aqueduct, the dam actually built in or along the Aral Sea many, many years ago. Back in the 50s, the Soviets decided to build a dam. And so you can see it was at one point the fourth largest lake in terms of surface area in the entire world. And the Soviets built this dam over here in 1999, which diverted the direction of a couple of rivers and where this fresh water would end up. And very sadly, you can see here in 2015, all of this area has dried up because of the diversion of water. And so, you know, this was an expansive area that gave a lot of people, provided a lot of fresh water. And now it's down to this little sliver of water here, which is the South Aral Sea. And up here we have the North Aral Sea, which is still under the control of Russia at this time. And then getting towards these last slides, we have desalination, which is mankind's way of trying to convert salty water into fresh drinkable water. And it can happen through a couple of different processes. One is by way of distillation, and the other is through reverse osmosis. This next slide is very important because it shows you how both of those processes occur. And so this first picture here is going to show you by way of distillation. The salt water is going to flow in these copper tubes, which it's going to be cold water at that point. The water is going to come down here, and we have a heating element as if it was on top of a stove, which that's a very small comparison. It's a much, much larger process. But you have a heating element, mind you, that needs to be heated somehow, so it's going to require energy to heat this element. Anywho, it heats the water boils, the steam vapor rises, it hits these cool tubes that the original water is coming through and condenses, much like water will condense on a cold mirror in a bathroom when you take a shower. And then the fresh water is going to fall and be separated out and then allowed to leave the system by way of this fourth area here. What's left behind is extremely salty water called brine, and it's very difficult to get rid of brine because no matter where you put it, whether it's on land or back out in ocean water, what you're doing is introducing water that is extremely high in salts, and that can actually cause different kinds of problems for the animals, plants, and water that you're putting it into. So that's distillation.